Welcome to MySci Unit 14, Bugs and Blooms. This is a third grade life science unit where students explore the life cycles and variation of plants and animals. Let's take a look into the unit at a glance. This unit covers several third grade life science standards about life cycles, animal behavior in groups, inheritance and variation, advantages of variation, and the influence of the environment on traits. One physical science standard on electric interactions between objects not in contact is partially covered. One second grade life science standard partially covers the function of animals pollinating plants. Most of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. We have integrated all dimensions of these standards into the unit. If you'd like, take a moment to pause the video and review them. This unit is divided into 3 sections. Each section has a driving question designed to reflect what we anticipate students would naturally ask through the learning process. In this unit, each section also has its own anchoring phenomenon. Section 1 has 3 lessons, and Sections 2 and 3 each have 2. The unit will take about 29 days to complete. The anchoring phenomenon of Section 1 is bees are often found near flowers. This theme connects to students through observations they might make in the world around them about bees and flowers. After being introduced to the first anchoring phenomenon, students may ask what part of the flower bees are visiting. The driving question of Section 1 is, why is the bee on the flower? Students will first observe and model the life cycle of a plant. They will then consider how bees help the plant and investigate how they can use static electricity to collect pollen and pollinate flowers. Students then explore how bees work together in social groups, which helps them all to survive. Students use these understandings to connect back to the driving question and phenomenon to connect the bee, flower, pollen, and hive. They will learn how everything is interconnected. Through the storyline of Section 1, students gain an understanding of these standards-based big ideas. Plants have a standard life cycle that begins with the seed and ends with the death of the plant. Electric forces can exist between objects not in contact, like bees and pollen. Some animals work together in groups to survive. Combined, introducing this anchoring phenomenon and Section 1 should take about 10 to 12 days to complete. The anchoring phenomenon for Section 2 is, pink katydids are rare. Students will generate questions based on this phenomenon. They will probably ask, what in the heck is a katydid? Section 2 engages students with the driving question of, why are there more green katydids than pink katydids? Students investigate how variation in traits can help some organisms survive and reproduce better than others. Next, they will investigate variation in traits and how some can be inherited and others come from the environment. Through the storyline of Section 2, students gain an understanding of these standards-based big ideas. Some differences in characteristics between organisms help them survive and reproduce. There can be variations of traits among similar organisms. Traits can be inherited or influenced by environmental conditions. Section 2 should take about 7 to 9 days to complete. The anchoring phenomenon for Section 3 is, a mealworm becomes a darkling beetle. Students will generate questions based on this phenomenon. They might ask, how can a worm become a beetle? And yes, we know some of you might not enjoy these bugs, but we sure hope your students love them. In Section 3, students consider the final anchoring phenomenon by observing and modeling the life cycle of mealworms. Students will then research another species of insect, their life cycle, whether or not they use group behavior to survive, and how variations in traits help their insects survive. Students will create and set up an exhibit of their insect and visit them all to compare. Don't worry, these exhibits don't include live insects, unless of course you want them to. Through the storyline of Section 3, students gain an understanding of these standards-based big ideas. Animals have a similar pattern of life cycle as plants: birth, growth, reproduction, and death. Insects have similar life cycles, but parts of their life cycles are unique. Some insects live in social groups. Variations in traits among insects help them survive. Section 3 should take about 7 to 8 days to complete. Our team here at MySci hopes you and your students enjoy bugs and blooms, and we look forward to your feedback. Happy MySciencing!